Hello and welcome to another project with spreadsheets using Google Sheets. Today we're going to look at a set of data that is a little bit closer to our campus. So in 2019 we sent a student named Christian Smith to a program called Rock On, which is a pretty cool project through the Colorado Space Grant. And they go out to the East Coast and build a rocket. Well, they don't build a rocket. They build a satellite that goes up in a rocket. This is what they build, is this thing. So it's a little bit of soldering, some programming, some gluing, So they build these little disk satellites, and then those get stacked inside of this big rocket, and then it gets launched into low Earth orbit. And a bunch of them fail, some of them don't work, but ours worked. Ours worked really well, and we got a huge data set out of the deal, and you're going to play with some of it. Now, I've truncated the data and cleaned it up a little bit, but I haven't done a whole lot of analysis of it. I've made a few visualizations using some Python scripts and things like that, and just kind of generally made sure that the data was there and made it so that I could truncate it, so I could figure out what to cut off, because there's so the rocket goes up into the sky really fast, and then it arcs over in outer space, and then it blows apart, and a parachute's deployed, and it comes down to Earth, and then it lands in the ocean, and it floats there and bobs for a while before the rocket is recovered. And so I'm sure you can imagine that it collects a lot of data of it just floating around in the ocean, so like an hour's worth. So I cut off all that, and that was like a lot of data, like at the very end of the thing. And so what I've done is I've smushed it down to basically what I believe to be the launch, the period of time that it was in outer space, and the part where it splashes down. I think I've got all of that in this data set, in this CSV file. So I'm pretty sure that's all of it, although if anything doesn't look right, be sure to let me know. I think this is it. And if anybody wants the whole data set, I'd be more than happy to share it with you. It's a fairly large file. I have it stored in a repository online, and it's freely available for anybody that is interested in looking at the whole thing. I think it has the same number of fields, but it's not... but it's a really stinking big piece of data. So this is the satellite. I just kind of want to point out a few features. This right here, I can't remember exactly. So here's an SD card reader. So this is where it was storing the data. It was on an SD card in this. We have this at the college, by the way. You can come and see it when we reopen the college. And our students, this is our student's signature on here. So this went to outer space, and then the other three people that he worked on this with all signed it, and then they shot it into outer space. It's pretty cool. There are some interesting parts that you can notice. This thing right here is a Geiger counter, so this counts like radiation particles in the air. This is a little beeper. That's like a piezo speaker. We've got a couple of MOSFETs here. I think these are basically transistors, this thing and this thing. I'm not entirely certain what all these things do, but I know what some of them do. This is where most of the sensors are, if I'm not mistaken. So this little emblem right here is saying what side should be up, basically. So if you think about three axes, so if you hold your hand like this, your thumb is the z-axis, your pointer finger is like the x-axis, and your middle finger is the y-axis. You can point in three directions, and that with three numbers you can pinpoint somebody's location in three-dimensional space, or in our case, acceleration in three-dimensional space, because that's what the accelerometer, the three-axis accelerometer, detects how much it's moving in a particular direction. And you'll see that in the data. You'll see the part where it's going up on the z-axis, which is along the length of the rocket. So that's the z-axis pointing up, and then you can see it kind of like shaking and shuddering as it kind of wobbles back and forth on the x and y-axis. It's pretty neat. And then when it splashes down, all three axes are kind of basically working at the same rate. And it has 3 accelerometers in it. It takes 3 different readings for the z-axis, and I leave it to you to kind of maybe see if you can figure out what they mean. And there's not really a whole lot of wrong answers here. I'm not looking for perfection. I'm just curious to see what your speculations, how they align with this, with what you're seeing. Like, oh, I think this might mean this. So when you do your write-up on this project, don't think that there's going to be like, I'm going to come down on you with the sword of Damocles. I'm just looking to get your interpretation of what you're seeing, because that's part of what we're trying to figure out here. Is we're trying to learn, like, when I have a set of data and I have no idea what's in it, what do I do? You know, so I'm trying to get a sense. I'm giving you guys a chance to kind of play with the data. Just play with it as if it's a toy data set that you can do whatever you want with and see if you can't find anything interesting. And I think you will find some interesting stuff. But I'll show you a few things first. So let's zoom way in. Okay, so the data here. This time you're actually going to be downloading it straight from my website, and I did this on purpose. It'll download the file. I'm going to download it to my my downloads folder. And the reason I'm doing this to you, and I'm going to actually open my downloads folder and show it to you, is so that you can see what's in this file. And I want you to know that when you get a CSV file, you can do something with it. You don't have to worry about you don't have to be scared of these things. They behave in normal ways. It's just a text file. Now, you don't want to go around deleting anything in here or changing it, but you can look at it and you can see that all it is a text file. And so you see here the first field is going to be the timestamp. So that's this field right here. The low x-axis acceleration is here. The low y-acceleration is this third number. And then there's the low z, and then I think medium x, y, and z, and then high x, or high z. And I don't know necessarily what low, medium, and high means. I didn't actually look it up, so I'm going to leave that to you to figure out. You've got a temperature field. You've got pressure in pascals, so that might tell us our altitude at any given time. What was that? Humidity? Oh, Geiger counts. This is how many Geiger counts there is. What's the next one is... Geiger counts is one that actually might look really good as a bar graph instead of a line graph, because then you'll see like at what timestamps there were the most ticks on the Geiger counter. And maybe even compare that with like altitude or something like that. So you've also got gyroscope, which shows a rotation about a particular axis. So that might be interesting to compare with like acceleration and stuff. I'm going to be asking for like 3 to 4 charts based on this data using Google Sheets. Well, let's get to that. Let's close this out. So say I have the data downloaded here. What I want to do is have my drive open. Open Google Drive. Because we're going to play with this in Google Drive. So you go to your ITECH 150 folder, and I'm just going to take that rock-on data trunk for truncated and just drag it in here. So once you have it uploaded to Google Drive, what you can do is open it in Google Sheets. And what that will do, it'll open in a new tab. What that will do is it'll actually create a new file, which will appear here shortly. There it is, a new Sheets file based off of this. So this data is now still safe. You can't hurt it. It'll be fine. Google Sheets does not give you any way of editing the original CSV file, so it'll automatically create an actual workbook for you. Now, this is a huge data set, so you may run into some performance issues. So I'm going to show you some ways to maybe mitigate some of those performance problems. Whoops, I clicked the wrong button. Yeah, it's 33,000 rows of data, which is a lot. So we'll go back to home. Okay, so here's the process for building a very simple line chart using this data. And you'll notice that there are going to be some minor time delays as I do certain operations. So what I'm going to do is add a sheet and call it chart 1. And then on this sheet, I'm going to create a blank chart. Insert chart, Boom, no data, blank chart. Over here, I'm going to say that I want a line chart, and the first thing I want to do is add our x-axis. So we say add x-axis, and that brings up a dialog that says select data range. So I want to put a data range in here. So my x-axis is going to be, so once I click back over here, it actually, there we go. And then I'm going to just select column A. Just click on the A up here. And then you'll notice how this syntax works. It says rock on data trunk, which is the name of this sheet, with an exclamation mark, and then A column A colon A, which means just all of column A. So all the data in column A. It is smart enough to know to stop at the bottom of the actual data. Once it starts hitting empty cells, it stops like reading them. So you hit OK. You still have no data, but you do have your x-axis. Now all you need is some sort of series. So we'll go select data range. We'll go rock on data. And right now A is selected, so it's going to automatically assume that. But we're going to try, let's try low axis, low Z. Acceleration, low Z. So Z-axis at low, yeah, I'm going to leave it to you to figure out what low, medium, and high mean, and why the z-axis gets 3 and the other two only get 2. The z-axis is special because it's showing us how much it's accelerating. And boom, here we go. Look at that. We've got a chart that looks like something. If you do it like this, you will notice that there's some slight delays between clicking things and things happening because this is such a large data set, but it will work. You'll notice here, this is the launch, this first initial part. So we're talking about like when certain events occur. This is when that would be. This right here, I think, is like when it hits apogee and things start deploying and, you know, parachutes are deployed, because it's a really chaotic period of time. Over here, I think, is when it hits the ground. Or the water. This is splashdown. I think that's what this is. Because it's moving downward, it's accelerating at a downward rate, and suddenly it's accelerating downward at a slower rate than it was before. My guess is, from looking at these numbers here, the acceleration is, let's go down to the bottom, 343 on the Z. So this is X. XYZ. So 347. I guess this is something like centimeters per second. I'm not entirely certain what the unit of this is because it's not meters per second, because it would be like 9.8 meters per second squared. So must be something. There is going to be some acceleration because there's gravity. It's called acceleration due to gravity. So if you're just sitting there, you should be reading something from just gravity. Any accelerometer, its z-axis, if it's pointing straight up, will detect gravity pushing it down. So I'm assuming that's what this is right here. And so and then it's a little bit jumpy here. The line seems thicker. That's because it's sitting in the water and kind of bobbing up and down and stuff like that. So that's kind of like the basic story of this rocket launch. So try looking at this and compare it with the other data series. If you lose that right sidebar and you want it back, you can hit this and hit edit chart, and then it'll pop up. If you're noticing that you have really serious performance issues, let me know, and we'll try to come up with a better system for working with it. But I don't anticipate, as long as you like take things really slow and be patient, you shouldn't have too much trouble with the with performance, but you never know. Make sure you put a title on it. Chart title. So this is z-axis. Notice how there's some lag here. Z-axis acceleration. I'm not entirely certain what the units are on that. I'll see if I can figure it out, and I'll let you guys know by Monday when we have class. Anyway, yeah, this is it. This is what we got. And I hope you guys have some fun with this. Play around with it. Don't overly stress about it. Look at the assignment carefully, what it's asking you to do. Look at each column, see if you can figure out what it is. Once you think you know what the data actually represents, build a few charts. Do they look like how you think they should? I'm looking for 3 or 4 charts in total with explanations on what each one represents. So this is a rocket launch, so there's certain features that are going to be obvious or evident in certain parts of this rocket launch. And do a brief write-up on an empty sheet that kind of explains the story of like what you think this data is telling you, like why certain pieces of data seem to spike at certain points in time, things like that. Not super, don't have to be super crazy. And again, ask me if you have any questions. I will explain. We can work through this together. Like if you're really not sure what the data is telling you, then let's just meet and let's talk about it. So on some level, we can work on this stuff as a group too, as a whole class. So you guys are one of the first groups of students to touch this data. So we don't have a whole lot of experience to go on. So I'm curious to see what you guys come up with. Good luck.